library project, which brings up the schematic library editor. And this is very similar to the schematic editor. You'll see a lot of the same tools here with the addition of this pin tool. And we'll take a look at the options first. We can go to document options by right-clicking, or we can go to the home, library, and then options here. And what we can set up here is our different sheet sizes or a custom size. We can change the workspace color. I like a nice light gray color, easy on my eyes. And I also like to always show the comment designator. A couple options here that we could set. And then the grid too. I'm just going to make the snap grid 1 for right now, so I could do some precise placement. It is important that your pins are on a 10 snap grid for the electrical connections. We'll talk a little bit about that when we go to place the pins. All right, you see my designator and my comment locations are now shown, and I got that nice gray back color. So the component that I've chosen to create today is just a simple NPN transistor. And I'm just going to go ahead and draw it out using some of these drawing tools. I'll start with this polyline. While I'm placing it, I can hit the Tab key, and I can set any options I want, line, width, and color, of course. I'll just go ahead and draw this line here. And then add a couple to complete the shape. All right, it's not too bad. And then I'll add a little polygon arrow down here at the bottom. So I'll just click that polygon tool. And then I'll click wherever I want to place those vertices. And then the zooming and the panning, of course, works just like the schematic editor. You right-click to grab the workspace and pan it around, then use the mouse wheel to zoom in and out. All right, that looks pretty good. Go ahead and set up some properties for this symbol. I can open up my library panel right here from the View menu. And this is where you create and manage all of the components inside this library. It does come with the one default component that we're working on now, and of course you can add more to it. We'll just go ahead and work on just this one for right now. I'll double click it to get into the properties and give it a name. I'm just going to call this one NPN. And then default designator, I'll put a Q question mark. This question mark is important. This will be replaced by the number whenever you annotate or when you're placing these symbols. We have an auto increment feature so that this will automatically increment as you place multiple. For the comment, I'll just put NPN, and then you could put in whatever description that you like here. And then I can also add any parameters that I want. Since this is a generic, it's probably not a good idea. But just so you guys know, you can just enter any parameter you want right here, and then a value for it. And then I can choose to make that visible on the sheet or not. Same with the comment and the designator. I'll go ahead and only show my designator for now. And then down here in this model section is where you can add your footprint and also simulation models. But we haven't created the footprint yet, so we'll get back to that in a couple minutes. All right, there's the designator and the shape. All we have left is to add some pins to it, and we can do that right here from the home menu. So you'll notice this pin at the top of it, there's a small X there, and that's what's known as the electrical hotspot, and that's where the wire is going to connect to. So it's very important to know the location of that electrical hotspot and to put it away from the component. And to make it a little easier on me, I'm just going to go back into my document options and set the snap grid back to 10. These lines aren't critically placed on the electrical grid, but the pins are. So it's very important to place your pins on your electrical grid so that there's when you're actually wiring the schematic, the wires will connect perfectly to the pins. I know all of the components that Altium creates in their Altium content vault use that 10 snap grid spacing. And I'll hit the space key to rotate it around. You see I got that hot spot over there to the left. After you place it, you'll see the hot spot has these four boxes, so you know which end will connect to. And I'll go ahead and place a couple more. You'll see the numbers automatically incrementing for me. I can just hit space to rotate it around. There's the auto pan there. It's kind of quick, but the auto pan setting can be changed right here in the file system preferences. And you can slow it down a little bit. All right, there we got the symbol and the pins. Good so far, except these names are kind of all jumbled up here. I can use a global editing feature, the inspector panel. I'll quickly select all these pins just by holding shift and clicking on them. Then I can pop open that inspector panel where I can edit multiple properties of multiple objects. And for this one, I'm just going to uncheck the show name here. And maybe I'll just move this designator. And then maybe I want these pins, it looks like they're overlapping my drawing here, so I'm just going to send those to the back. And I can do that right with this move command, move send to back. And then I'll just click right on them. All right, that looks pretty good. I'm going to go ahead and save it now. I'll just give it a name there. It'd be a good time to save my library package also. All right, now we're going to need a PCB footprint to link these pins to. So I'll go ahead and add a new PCB library right to my project. And then here's the reference. This will be 00 if you notice down at the status bar. Looks a little bit different from the reference location in the schematic editor here. You'll see it's just where the grid crosses. And then in here I can place my pads to match up with my pins. I'll just use the pad tool right from the home place menu. And while I'm placing it, I can hit the tab key to bring up the properties just like I did with the pins. And I can assign it a designator, which will, of course, want to match the pin over on the schematic side that it's connecting to. I can also set up different sizes and shapes. Let's see, this one I'll make kind of an oval shape. Let's do 75x and maybe 45y. We could set the whole size too. I'll just leave that at 30. If you were doing a surface mount component, you would want to set this to top layer. Anytime you make a surface mount component, you want to create everything on the top layers, and then when you go to place that on the PCB and you flip it to the bottom layer, everything will automatically change to those bottom layers. But while you're creating it in a library, you should put everything on the top. This one's going to be a through hole though, so I'm just going to make this multi-layer. And then you could set it plated or not plated if you're just making, say, a mounting hole. There's this cool preview here too, where you could see all your different solder masks and paste mask expansions. You can either specify those in your design rules or right here on a per pad basis. Looks pretty good. I'm just going to go ahead and place it right here. Then I'll place a couple others, and you'll see that they auto-increment. That looks good. You can set up this grid spacing to match your data sheet, so it's really easy to place the pads in the correct locations for whatever you're creating. And maybe I want some silkscreen information on here. I can go ahead and put that right on the top overlay, and I can draw it out using these drawing tools. Maybe for this one I'll just make a nice circle here. And I can go in the properties and edit these values to whatever I want. Go with the width 6. These are some values that I figured out earlier that would look good for this, and instead of wasting everybody's time trying to draw a nice silk screen here, I'll just go ahead and enter these in. And then you could change the layer right here if you didn't select your layer off these bottom tabs before placing it. All right, that looks good, and I'll just complete the shape using this line tool. All right, not bad, and I think the only thing left for this footprint would be a 3D body. And I can add that a couple ways. I can go right here to the home 3D body. I could create like a simple extrusion. I just need to give it a height. And then I just draw a polygonal shape here. And just a real simple extrusion. I could also attach a step model right to this. I would select generic here, and then I would just browse to my step model. Just pick this random one here. Oops. Let me try that one more time. I hit the wrong button. And then I just place where I want it. To get a little more detail there. And another option that's really cool is in here in the Tools menu, we have this Manage 3D Bodies. And here you can see all the 3D bodies associated. Right now there's none, but we can create them. And we can actually create one from this polygonal shape on the top overlay, which will match that silk screen exactly. And all I have to do is hit this body state so that it adds it to the component. I can set my standoff and overall height. And there you go, a nice 3D body that made very quickly. It matches that silk screen. So let me go ahead and save this out. Make sure I gave it a name in here. And then I'll just do a save all to save my project and all the libraries inside it. All right, now I'm ready to attach that footprint over to my symbol. So I just open up the symbol properties here, and in this model section, just click Add. Footprint is what I want to add. And then I can just browse all of the available libraries. And now I just have this one that I created and the one footprint inside it that I created, so that's what I'm going to use. I can preview it in 2D or 3D here. We can see it got added. And then all I'll need to do is save that schematic library, and then I'll want to compile my lib package into the intlib. And this is going to take that library package, and it's going to compile it based on the rules that you have set up here in the project options. It'll notify you of any errors or warnings. And this looks good because I matched up all those pin numbers. It looks like, actually, nope, could not find port 3 on model NPN for pin 3. That's perfect. That's a great example. So we can see here in my schematic library I have 1, 2, and 3. But over here in my PCB lib, I have 0, 1, and 2. So that's going to cause us a problem in the future. And it's a good thing when we compiled it notified us of those errors. And I can go in here and I can quickly change those pads to match. There we go, that's a little bit better. We'll just go ahead and save everything, and we'll try that compile again. And you'll notice that messages panel, it didn't automatically pop up because there's no severe errors or warnings, but I can still get to it from my View tab and Messages. And yep, compile successful, no errors found, very nice. So when I compile that, it's going to add that integrated library right into my libraries panel. And I'll be able to now select it from this drop-down list here. But if I wanted to install it, I could just hit this libraries button and I could install it here at either the project level or the system level. In this install tab, the library will be available to all projects, or in the projects tab, it will only be available to a certain project. Now that I have that in my libraries panel, I can just simply drag and drop it right onto a schematic. Or I can use this place button. And if I hit tab while I'm placing, I can enter in a reference designator, and it'll auto-increment as I place it along here. Then you'll notice that electrical hotspot, the 4 dots, and that's where I can connect my wires to. I'll just place some random wires here so we can see the nets get transferred over. And then I'll just push these symbols right over to my PCB document. I get the engineering change order, shows me what's going to be added, the symbols and the nets, of course, and then a component class here. Based on my schematic sheet, I only have one schematic sheet, so it's going to create one class and add all components on the sheet to that class to make design rules easier. And then we'll see those components were added to the PCB with their rat's nest or connection lines there so that I can get them routed up. And if I hit the 3 key, I'll go into the 3D mode, and you can see those, just the simple extruded bodies that we created in the model manager. That's a quick overview of creating an integrated library with a symbol and a footprint. And I really could have saved myself a lot of time if I would have used an already created component from Altium's huge Altium content vault. There's over 350,000 components in there now, and they're growing every day. We got a whole dedicated team of people updating the components and adding new ones. To get to the content vault, you do get it with subscription to CircuitStudio, and all you have to do to add it is to go into your system preferences from the file menu. Then you go into data management, vaults, and just hit this add Altium content vault button. Now I'm connected to the vault. To access it, I'll just go to File and Vault Explorer. So in the unified components, we have a lot of cool generic capacitors and resistors, and also all of these different manufacturers. And you could browse through and select the components you want, or you could search up here in this search box, which is really nice. The thing I recommend searching by is the manufacturer part number. I seem to have the best luck finding components with that. So I'll just search for NPN and see what I find. Looks like some good results here. Take a look at this audio transistor. And then you get a couple things with all of these components in the vault. You get the schematic symbol, of course. I could have just copied this one here. It would have saved me a lot of time. And you also get the PCB footprints along with the 3D model. Some other stuff you get here is this supply chain and life cycle information. You can see how many different revisions the component's gone through. And we have a direct link to all of these different suppliers. So you can see the pricing and the availability, price breaks. If you have an account with any of these suppliers, you could set it up in your system preferences. And that way you get the correct discounted pricing and everything. And this can really save you a lot of time and the money in the future by allowing you to select a component that's available with a decent price instead of trying to do that later down the line after you've already created your schematic and your PCB, and then you found, oh no, we can't get this transistor anymore. We're going to have to find a different one, and maybe we'll have to change the layout a little bit. Maybe we'll have to change the schematic a little bit. It can really save you a lot of time and money here. And you can add this supplier information directly to your own components too, the ones that you create or import from other programs. To place one of these components from the vault, you just need to open up your schematic, and you could drag and drop right onto your sheet. Or you could right-click and do a place. And you'll see all that great supplier information comes along with the part. So if you hover right over the top of it, you should see our supply information appear. Also, if you want to add that supply chain information to a part that you've created or imported, you could just right-click right on it and do supplier links. You could do this at the library level or at the component level already placed right on the sheets. And then here you could search. We'll just search for NPN. It'll give us all these different choices here. We'll find something suitable. And you'll see that same great quantity and pricing information here included. And I'll go ahead and add that right to the component. That's just a quick overview of creating a component and a little bit about Content Vault, how to search in there and place components from it. For those high pin count parts, I don't think we have a feature available just yet in CircuitStudio. So it would be mostly a manual process of drawing out the shape and placing those pins manually and giving them the electrical type and the display names that you wanted. You would draw out your shape using a rectangle or whatever shape you wanted, and then you would go through and place all of your pins in there, of course. And as you're placing them, you could set the electrical type and then also give them a descriptive name here. That's something that's a little beyond me. I might have to look into that and get back to you on either a comment on the website or an email directly.
Sure. When you hand that over to me, I'll post it for everyone.
Yeah, I think I'll have to get an answer on that, and then we'll post it on the comment section of the page.
Sure.
Because that's not something that I've dived into yet myself. Yeah, really easy to make multi-part components on the schematic library side. You just need to go into your tools and hit the new part button with your component selected. I'll go ahead and add two new parts here. Now you can see it's a multi-part component. I can edit each individual part, and then I could link those over to a single footprint. So really easy to create multi-part components. You can also create alternate views, which is kind of like a different graphical representation. And to do that, you just hit the Add mode, and then when you place the part, you can select which view that you want for it. So you could have multiple different graphical representations of a symbol. But of course, you want to keep in mind that you want to keep your pins exactly the same through all the different representations so that those pins do link up to their footprints. Oh yeah, the multi-parts will work just like I showed, and they will be designated, like he said there, U1A, U1B, etc. Yeah, you could create a step model and then export that out of SolidWorks and then attach that right to your footprints. Now you could also bring in a step model and then add that to a component and place that on your board and use it for an enclosure so that you can get your board to fit the enclosure perfectly. Be more of an advanced question. If you go into your schematic, under your tools menu, you'll have run XSpice simulator, set up XSpice simulator, and generate XSpice netlist. And you need to attach those SPICE models to your footprints first, and then you'll be able to run your simulation right here from these commands in the tools menu. There's a simulation example that I believe comes with the software. Yeah, if you do get an eval or get a hold of the software, if you go into the examples folder, there's a great simulation examples in here that you can play with. And all these come with all their SPICE models. Can you save a component from the vault locally? What you can do is you can go into the vaults and you can choose the symbol or the footprint, and then you can clone that and then copy it right into your own library. So if I were to preview, I'll take a look at this symbol here. Maybe I want to grab that one. I could just right-click on it, and I could do an operations and clone. And then you'll see in my projects panel, I have a new free document component here, which is basically just a schematic library with that component that I've copied. And then I could just copy that into my own library. So yeah, you can definitely get the footprints on the components right out of the content vault, which is nice because maybe there's a component that doesn't exactly meet your needs but is similar. Maybe you could take the symbol or the footprint from it and slightly modify it to suit your needs, which can still save you a ton of time. Yeah, and even if you disconnect from the vault after you place some of those vault components, all that information is cached in the schematic sheets and the PCB. So you don't need to stay connected to the Altium content vault after you've placed your components. But if you want that live, that great supplier information with the pricing and the availability, you'll need the link to the vault for that. And that information is coming directly from the suppliers themselves. We're connecting directly from their server to get that real-time information. Okay, there's a question here. Can you clone cache components from the vault if you're not connected from the internet? If you're not connected to the internet, you won't be able to perform that clone process. So you will have to be connected to clone from the vault.
Nate, I guess to clarify, you have to connect to the vault first, clone your part, and then you can disconnect from the vault.
Right. You cannot clone the symbol just from your schematic sheet like he's asking, where it's cached. It has to be cloned from that Vault Explorer panel. And to access this panel, you do need to be connected to the vault. So to clone the component, you do have to connect to the vault is the answer.
Oh, okay. So you still have to connect to the vault to clone a part, even though the part is a cached part?
Right, the part is cached on the schematic, but if you want a copy of it to add to your own library, the only way to get that is to right-click on here and do the operations in the clone. and that'll give you the symbol that you can actually edit and copy the pieces of it, like the lines and the pins and everything. You couldn't just copy a component from your schematic right to a library. So if you want anything out of the vaults for use in your own libraries, you do need to be connected to the internet and to the vaults when you're performing that clone operation. And another thing, if you update a symbol or a footprint inside your library and you need to update your schematics or your PCB, you could just right-click right on your component and select Update Schematic Sheets. And all those changes will be added right to the sheet, which is just that square that I added there. See, I updated again and took away the square. So even if you do update your symbols and your footprints in the libraries, you can keep your schematics and your PCBs right up to date with them. Can you share personal component libraries with others? That's another great question. And yeah, the integrated library is a great way to share those components because it's a lot more difficult to edit. So you can create the component that way that you want, send it over to somebody else and not have to worry about them making any strange changes to it. And you can share your schematic libs and your PCB libs with them too, of course. If they want to add it to their program, they just need to go into their libraries panel and then browse right to it. They can install, of course, at that project level for just the project that's open or at the system level for other projects.